How do you solve this problem? Well, we need to find the vector components for this vector right here. Now we're going to call this little guy v, okay? And now let's find its vector components. So first of all, let's make a drawing so we can see the vector. Now remember that we have 30 degrees, which means that we need to draw a line that has an angle of 30 degrees with respect to the x-axis, which is going to be this one, and this is going to be y, okay? So we could say that this is 90 degrees and we need the third part of that angle, which let's say would be something like this, okay? Yeah, maybe approximately like that. And now we need to make sure that this line right there has a length of 12 newtons, okay? And this is going to be 30 degrees. Now we need to find its vector components. And those guys are, so let's make a little line right here. Okay, now that sucks, but yeah, you know what I'm doing. This is just so you can see the line, okay? This is going to be Vy, and this is going to be our x component, which is going to be Vx, okay? Now we see the two lines. Remember, this is basically as if you had a right triangle, something like this. This would be 12, and this would be A and B, and we need to find A and B, basically. We need to find those magnitudes. So let's do that. So we know, first of all, that we have 30 degrees, and we need to find, let's go first with By. So let's find an equation that relates this angle, this hypotenuse, this is a hypotenuse, and Vy. If you remember some trigonometric functions, remember that the sine of any angle alpha is going to be equal to the opposite side over the hypotenuse. And now this is pretty useful because we can say that the sine of 30 degrees is going to be equal to the opposite side, which is going to be Vy, our y component, over the magnitude of the vector, which is going to be h. Okay, and this is just going to be bar, vector bar, okay? Now, how do we find Vy? Well, we can rearrange everything, and you're going to have that Vy is equal to, multiply this on this side, and you're just going to have magnitude of the vector times sine of 30 degrees, okay? Now, let's plug that into our calculator, so we know this is just the same as if we did, and not V2, Vy actually. Vy, let me write that again. So Vy is equal to 12 newtons, I'm going to write the units later on, times sine of 30 degrees newtons. And this is the same as, that's pretty interesting, that's just 6. Okay, 6 newtons. That's right, now this is just simply Vy, our y component. Now let's find our x components. So how do we relate the x side, or you could say the side that is on the x-axis, for a right triangle? Well, if you only have the angle that is on this side, then you can use cosine. So we could say this is just simply, let me write the equation first of all, like in standard form. So remember, the cosine of any angle is going to be its adjacent side over the hypotenuse. And now if we use 30 degrees, we're going to have that cosine of 30 degrees is equal to Vx, which is our adjacent side, over the hypotenuse, which is the magnitude of the vector. And now we need to find Vx. So we have that Vx is equal to the magnitude of the vector times cosine of 30 degrees, okay? And this is going to be the same as if we did Vx is equal to 12 times cosine of 30 degrees. And let's see in the calculator how much that is. And this is just going to be 6 times square root 3. Okay? And this is, of course, newtons. And now we just found our vector components. So we can say that this is going to be our answer. So we have Vy is equal to 6 newtons. And Vx is equal to 6 times square root 3 newtons. Okay? And this is the answer for the problem that we just solved, for the problem that we just created, okay? So, well, I hope you enjoyed this video, learned something, smash that like button, and see you in the following one.